What's going on, everybody? Mr. Glenn here, broadcasting from the sandy beaches of Hawaii, just relaxing and ready to get you your health and phys ed education. But are we really in Hawaii? I don't know. Maybe we're on the moon. Maybe this lesson's just going to be out of this world. Or maybe we're just at the refreshing waters of Lake Minnetonka. Wherever we are, I hope that you are safe and ready to learn. So you can see here up on the screen up top, we have the emails for the health and phys ed teachers. If you have any questions about anything, please email us. We'll be glad to answer any questions. Also over here, you can see some reminders to check Google Classroom frequently, as things will be going up and they will be needing your attention, responses, and completion, as we'll be posting assignments on there quite frequently moving forward. So the first thing we're going to talk about today, we're going to break this up into a few parts. We're going to talk about defense against diseases. We are actually going to display this in a full screen mode, just like this, so it's easier for you to navigate and see. And as well, I want to make sure that you're aware that this is posted on the Google Classroom's website. You can click on it, you can read it at your leisure, you can use it on the tests. Through the lecture portions of this, I am going to be going into a little bit more detail than is listed on the PowerPoint, so it is advantageous that you do watch this video and go through the lecture portion of the course. So first, we're going to talk about the physical and chemical defenses of the body. Now, all of these are both physical and chemical, with the exception of cilia, and we'll get to cilia in a minute. So on your test or on your exam, if it were to say if any of these were physical, chemical, or both, just a hint, they're all going to be both, with the exception of cilia, which is only physical. So we're going to talk about the skin first. So the skin is a physical barrier. It protects the inside of your body from pathogens and things that are on the outside of the body. Skin also sheds. So as your skin sheds, it's important to know that pathogens or anything that are on top of the skin are going to shed off with that skin. That is why it is so integral to make sure that you are washing all of your clothes, changing your bed sheets, etc., because your skin cells, though you can't see them in most cases, are shedding, and that is getting into your clothes and your linens. So make sure you take care of that. Also, there are chemicals that the skin will produce and secrete, particularly through sweat. And these are acids that kill bacteria and other pathogens on the skin. So the next thing we're going to talk about are mucous membranes and their openings, such as the mouth, the eyes, and the nose. They secrete a liquid called mucus, which traps a pathogen and it washes that pathogen away. So it physically moves the pathogen. And again, just like skin, the mucus does contain chemicals that will attack pathogens, kill, and destroy them. And next we have cilia. This is what I was talking about before. This is the only one that is strictly physical. And these are hair-like projections that line mucous membranes. If you think back to freshman year when we talked about smoking and we talked about the lungs and the lungs function when it comes to debris and such that gets into the lungs, the cilia helps to matriculate all of that stuff up out of the lungs and someone coughs that stuff out. Now, someone that is a smoker, the tar and such on the cigarettes that someone is inhaling will actually weigh down and mat down those cilia, and then what happens to that person over time. I'll give you guys a second to think about it before I answer. The cilia no longer work properly, and they develop a smoker's cough to try to get all of that stuff out of the lungs. Next up, we have saliva and tears. Now, these also, again, physically move things out of the body. They trap things and move them, moving pathogens out, and they also have chemicals that will destroy pathogens and kill them. If you've ever been hit in the face with a basketball or a baseball or even a volleyball, anything of the such, you'll see that a lot of times someone's nose will begin secreting extra mucus, their mouth will begin secreting extra saliva, and tears will begin running down their face. And that's because there's damage in that area. And you may think that the person is crying, but a lot of times that's just a defense mechanism of the body when there's trauma in that area to try to protect itself by producing tears, producing saliva, and increasing mucus coming out of the nose in order to try to defend against different things that it wants to defend against. And we're going to talk about the digestive system. There's chemicals such as acids in the digestive system that will help to destroy pathogens. Also, the motion of the digestive system and the excretion of different types of food items that you may consume that have pathogens on them. That's going to help enable you to stay safe. It'll either go out through defecation or somebody will vomit those things up oftentimes. So again, like I said before, all of them are both physical and chemical with the exception of cilia. So we're going to talk about inflammation. All right, so with inflammation, this is when there's damage to cells in an area of the body. It could be from trauma, it could be from a pathogen destroying cells. Whenever there are cells that are destroyed, the body is going to facilitate inflammation. This is when blood and other fluids go to the area. And the job of these blood cells are to do two things. One, it's to heal the area. And two, it's to get rid of any damaged cells and try to clean up the area as well. Now, there's inflammation that's positive and there's inflammation that is negative. When someone damages, say, their knee and their ACL tears, the inflammation in that area is sent in order to help to repair. There's also blood that's coming out of the torn tissue, and it will facilitate some type of healing, though you need reconstructive surgery to repair an ACL. But what actually may happen over time is that there may be too much inflammation. This can also happen post-surgery with the damaged cells from going in and fixing the ACL. In that case, when there is too much inflammation in a joint, oftentimes a doctor will actually use a syringe, go in and pull that inflammation out, because inflammation can be negative. It can impede range of motion. It can make it so an individual is not healing properly. So inflammation is something that can be positive, but something that doctors and you oftentimes will need to be cognizant of and monitoring constantly in order to make sure that there isn't too much. The immune system. We're going to talk about the white blood cells. And white blood cells called lymphocytes. They carry out most of the immune system's functions. And immunity is when the body is already equipped to destroy a pathogen that enters the body. So some of the lymphocytes that we're going to talk about here, we're going to talk about the T cells. We're going to talk about them in order of the way that they interact in the body with your immune system. So first up on deck, we have the helper T cells. The helper T cells produce chemicals that stimulate the T cells and B cells to begin fighting off an infection. This is where it starts. Then the helper T cells call on the killer T cells, and they go out and they destroy pathogens. They destroy anything that has antibodies. Antibodies are markers that the body uses that are produced by the B cells that mark things for destruction. So the T cells will go out. If something has an antibody on it, it knows that it should destroy that, and it goes in and it tries to kill that particular pathogen. Now the T cells, or I should say the killer T cells, can be positive and negative as well. Sometimes the killer T cells can destroy human cells, healthy cells, because it deems them as something that is a pathogen or something that shouldn't be there. So you have to keep that in mind also. The suppressor T cells keep the killer T cells in check. So once everything has been deemed to go back to homeostasis, which is the steady state of the body, the suppressor T cells will turn off the immune system, and it says, you know what, killer T cells, we don't have to keep killing. We're going to stop. We're going to stay cognizant of other pathogens that may come into play, but we're good for now. The B cells, they produce antibodies, and antibodies, again, are the proteins that attach to the surface of pathogens, and they mark those pathogens for destruction. So you may be thinking to yourself, well, how does the body even detect that there's a pathogen there? And the body uses a system called the lymphatic system. You can think of it as a filtration system for the bloodstream and for cells of the body. It's a network of vessels that collects fluid from tissue and then returns it back to the bloodstream. This fluid is called lymph fluid. you have hundreds of small stations called lymph nodes. Inside of these lymph nodes are the B cells. If a pathogen enters the lymph node and one of those B cells are sensitive to that pathogen, what happens is the B cell begins replicating itself. This is called clonal selection theory. And this is when one of the B cells begins replicating itself. As it replicates, it then releases antibodies. It then has the helper T cell tell the killer T cells to go out and kill. Killer T cells kill whatever is marked with an antibody, all of the pathogens, and then the suppressor T cell, once everything is in check, turns the killer T cells off and says, all right, we're done. We killed everything. You can stop killing. And then that is basically how the lymphatic system, the B cells, the T cells, and all of those things work together in conjunction. We're actually going to link to a video with this as a supplementary type of activity that you can watch. And you'll be able to see that right on the Google Slides page. It goes over all of the things that you're going to need to know for, actually, you know what? Let's just cut to it right now.
In 1960, Sir Frank Macfarlane Burnet was awarded the Nobel Prize for his contribution to the field of immunology. Burnet's clonal selection theory revolutionized our understanding of the immune system. To this day, Burnet's research remains the foundation of the way we think about disease and how the body responds to it. Clonal selection is the central mechanism by which your body fights infection. The following visualization presents clonal selection during an infection by strep throat bacteria. This patient has a strep bacterial infection causing a red, sore, pussy throat. The tiny round strep bacteria thrive on throat tissue. The bacteria are coated with hairs called M protein. M protein is what your body recognizes to be foreign. In response, your body will launch an immune attack against it. Your lymphatic network is an important part of the immune system, detecting any infections that arise in your body. The M protein hairs drain into the lymphatic system around this patient's neck. The lymph node is crammed full of B cells. B cells are guardians of your immune system, scanning the body for foreign material. Arriving at the lymph node are M protein hairs from the bacteria. Your body contains billions of B cells. Each B cell is unique and is sensitive to only one kind of foreign infection. By chance, one B cell is sensitive to the M protein hairs from the bacteria. This is the molecular surface of that B cell, magnified 10 million times. Its surface is covered with receptors that recognize M protein. The receptors grab onto the M protein hairs. This triggers an activation signal to travel into the cell. The activated B cell migrates and begins to replicate. In a few days, thousands of copies of the selected cell are made. This is the central idea in Burnet's clonal selection theory, where one cell is selected out of billions of B cells and identical clones have been created from it. Therefore, the cell is clonally selected. This creates an army of B cells that mass produce M protein antibodies and release them into the surrounding fluid. The antibodies circulate in the blood and travel into tissues. They bind to the M protein hairs on the strep bacteria. This flags them for destruction by the immune system. Other immune cells ingest the antibody-covered bacteria. They destroy the bacteria and eliminate the infection.
So that's going to be the end of part 1 for the immune system. You now have a few review questions that you're going to have to answer over on the Google Classroom homepage. Go ahead and check those out. Make sure that you answer those, and then you can move on to part 2.